Okay, welcome everybody to part six, pardon me, part 17 of the Introduction to Artificial Intelligence course. And today we're in Unit 3, and we're going to be looking at AI optimization in today's lecture. All right, everybody, I hope you enjoy. Let's get started. All right, so the first thing we're going to look at today is the concept of data literacy. So today is about the stuff that happens around AI that determines whether it works well for you in the real world. Like most AI failures are data failures. So let's talk about that. Before AI can help, it needs something to work with. And if the data it's working with is dirty or scattered or misunderstood, no good prompting can save you. You've learned how to write really great prompts, and you've learned how to change steps into workflows. So why would AI still mess up? Well, a great prompt sent to a great model working with garbage data will still produce garbage. Optimization is the term we use that where everything happens around the prompt. So let's dig deeper. The phrase garbage in, garbage out is a phrase from a computer scientist in the 1960s that helps really define modern artificial intelligence. Garbage in means things like inconsistent labeling, duplicate rows, mixed date formats, missing values, out of date entries, or no clear categories, which means we're going to get garbage out. We're going to get confident sounding, but very wrong answers. We're going to get double counted records, assuming them to be the same person. We have misread dates and trends and fake patterns from gaps and stale recommendations that are out of date and apples mixes with oranges. Data scientists, the actual people whose job it is to build AI models, they spend about 80% of their time just cleaning and preparing data, and the model building is the other 20%. So to avoid this problem, let's implement 3 data jobs: clean, structure, interpret. Starting with clean. What this means is let's spot and fix problems before the AI sees the data. Things like inconsistent spelling, the spelling of the word Winnipeg versus lowercase w Winnipeg versus an abbreviation of Winnipeg, or duplicate rows or blank cells or ambiguous dates. To a human, those are obviously the same city, but to AI, those might look like 3 different places. Next, we look at structure. Structure means organizing data so it has very clear columns, consistent types, labeled categories. Structured data is way easier for AI and really for you to work with than just a folder of all mixed up files. And finally, interpreting. This is the tricky part. As clean and well structured as data can be, it can be still misread. For example, ice cream sales, they correlate strongly with drowning deaths as both go up at the same time. AI might report that there is a correlation between these, that eating ice cream causes drowning. But ice cream doesn't cause drowning. It's summer. That's the factor that correlates there. And humans have to interpret while AI just reports patterns. So what does dirty data actually look like? Well, here's the same data set, but 4 problems are in it. Let's take a look if we can find those 4 problems. So one problem we can see is the city names are inconsistent. We have Winnipeg with a lowercase w, Winnipeg with a capital W, or the abbreviation for Winnipeg. Are those 1 city or 3 cities? Here's another problem. Row 1001 appears twice in this table. It appears as the first item in the table and the third item in the table. So we have a duplicate row. A third problem is mixed date formats. So when these were entered, the date format might include the month, right? The day, the year with a slash in between, or the year, the month, the day with a dash in between, or not using a number for the month, using an abbreviation or the entire word. All these mixed date formats can confuse us, and it can confuse AI as well. So we're looking for consistency. And the fourth problem is we have a missing value there. Maybe that was the most obvious one, that there was something wasn't put in there. So it's missing a value, a blank row for that entry. So if you ask AI to summarize all of this, it will treat the duplicates as if they're different entries, the spellings as different cities, and it may guess very, very wrong on those dates because of our quote unquote dirty data. All right, so now that we've looked at data, let's turn our attention to tool integration. So if we're going to equip AI with some tools to get its job done, what are we really talking about here? So many of us use AI by just typing into an app, copying the answer, and pasting it into a different app. So let's give an example. So let's say you open up Google Chrome, you go to ChatGPT on the web, in a tab in Google Chrome, you ask it to prompt it, get an answer, copy it, and meanwhile you have your essay in, say, Microsoft Word or a different tab in Google Chrome and Google Docs. So you'll copy it from one, paste it in the other, fix it up, and repeat that process. This could be described as a silo problem. You are doing all the connecting. You're connecting the prompt and the output to, say, a Microsoft Word document. You're doing this manually. You're doing the copy paste. And AI doesn't know anything about anything other than the little browser tab it lives within. So this is a silo problem. ChatGPT lives in its silo. Microsoft Word lives in its silo. When we talk about integration, what we mean is connecting AI to our systems, to our tools, where our data already lives. Like, for example, connecting it to our calendar, like a Google Calendar, an Outlook calendar, connecting it to our email, our spreadsheets, our databases. Okay, the technical term that's often used in AI is a connector, or sometimes an API integration. And we're going to look at what that acronym means in a moment. This is just a fancy way of saying I'm connecting or linking two pieces of software so they can communicate or talk to one another. All right, so let's look at some analogies. On the left here, we see the silo process. You ask AI a question, it gives you an answer, you copy and paste it somewhere else, but AI can't really see your data. It's asking the same kinds of questions over and over. It's certainly useful, but it's limited. We're doing some manual copying, pasting. We can't see our real data, and we're asking that same question over and over, copy, paste, repeat. On the right, we're going to use the analogy of a stack. Sometimes this is called your software stack or your tool stack, right? In this, now our AI is connected to our calendar. So we've made a connection so it can talk to it. It's connected to email, connected to database, connected to something like an ordering system in a business. Now it can answer questions using the connection to your real data. It can do things like send a message on your behalf, update a record, etc. Okay, so now AI reads from the systems or the tools you actually used, your tool stack. It can answer with real current data, and it can take action, sending emails, updating databases, logging entries. So how do we do this? How do we connect and integrate a stack of applications to AI? Well, that's pretty complicated for an introduction course, but it depends on several factors. But I'm going to introduce 3 acronyms that you will encounter if you dig deep into this type of thing. And those acronyms are API, CLI, and MCP. So API stands for Application Programming Interface. It's essentially like a messenger that allows 2 different pieces of software to communicate and talk with each other and get structured answers back. Think of it as a bridge, or the analogy of a waiter in a restaurant. So let's expand on that analogy. If you're in a restaurant, you're sitting at a table and you look at a menu, you, the user or the person sitting in the restaurant, know what you want based on the menu. But you can't go into the kitchen. You can't cook it yourself. The kitchen, we'll use an analogy like a database, is where the food is. It's where it's prepared. That's where it has all the ingredients. That's where it has the stoves and the mixers and the cooks, the people to prepare it. It doesn't the kitchen doesn't interact with customers directly. The in-between is the waiter. And the waiter in this case is our API. It's the interface between the application and the code. You give your order to the waiter, who takes that request to the kitchen and then tells the chefs what to do, what to make, and then brings the finished meal back to your table. So APIs are what are coded into applications to make that connector between your AI model and some tool. The other one is CLI, or command line interface. So think of this like when you're using a program and you click a button or you type in some command. Well, typing is faster. It's more precise. It tells it specifically what to do. And typing is definitely something that AI can do instead of, say, clicking a button. So let's draw another restaurant analogy. So now you're at the restaurant, you look at the menu. Think of the menu like your user interface. Like if you're using Microsoft Word, that's your user interface. And you want to make some text bold, so you would click the bold button in Microsoft Word. But in this analogy, you pick an item from the menu to eat, like clicking it. But you're limited to what's on the menu, right? You can't go outside of that. A CLI would be more along the lines of having a direct phone line from your table in the restaurant right to the back where the chef is. So instead of choosing from a menu, you can talk to the chef directly. You can give specific, typed in instructions. Make me a hamburger, hold the pickles, toast the bun extra long. The benefits of a CLI is its speed. It's faster to type in commands or have AI receive typed in commands than to click select all and then right click and then delete and then confirm, are you sure? The command will give all the instructions directly to what needs to happen on the end of the tool. It is, of course, very good for automation or workflows, which we looked at in our previous lecture. So this is the big benefit in automation. You can string together a whole bunch of commands into a single script of instructions and tell the AI or the computer at 2 a.m. log into this server, pull these files, zip them up and email them to me. As opposed to if those were all buttons and commands, you had to click each button in sequence, you could give it the script of things to do and automate that process. And power. CLIs give you access to hidden things that aren't always in a standard user interface or they're not in the point and click menu. It allows you to talk directly to the operating system. Like in our restaurant analogy, if you're on the phone with the chef, you can make very specific requests of your food that aren't necessarily on the menu. The final one is, actually, let me pause for a second. Let's take a look at CLIs as they're used by coders. Coders will run their code. They will do things like manage servers. AI, when running a model locally on a local computer, will use a CLI to download and trigger those systems. And the system administrators who are managing things like networks or remoting in to fix computers, etc., well, they will work in computer terminals and write those scripts to integrate for that type of integration. So we'll look at this chart here, the GUI, the graphical user interface. That's what you're used to. You're used to things like opening File Explorer, clicking on a documents folder, right-clicking on old essays and choosing delete and then confirming that you want to delete. Whereas with CLI, it's the same task. We're going to get to the same endpoint, but now we're writing it all in one command line interface task, right, which you can see there. One line replaces 5 clicks, and the AI can write that line as easily as you can. That's what AIs are good at. So why this matters is agents, which we're going to look at in our next lecture. They act on the world mostly through those CLIs and APIs. They're not moving a mouse around, right? They are automating these processes. All right, now let's move on to that final acronym, the MCP, the Model Context Protocol. So this is a fairly new connector acronym. It's a shared standard that was created in late 2024 for how AI models, quote unquote, plug into outside tools. So how do I connect my model, my AI model, to the tool I want it to use and to the data I want it to read from? So a great analogy for MCP is it's like a USB, right? You plug it in and it just works. It's built specifically for artificial intelligence. Before MCP, connecting Claude to your Google Drive or Claude to your Gmail, you'd have to build this custom bridge. You'd have to write a code API integration for the services. You might have to write some sort of CLI, but that was messy and time consuming. It required a lot of technical knowledge and it was hard to manage. Whereas MCP creates this standardized language. Instead of building a custom bridge for every tool, you build one MCP connector. And once you have that connector, any AI that speaks MCP, which of course is going to be your most popular AI models like the Claude desktop app, they can instantly connect and talk with your data. So before MCP, every AI had to be wired to every tool one by one with a custom job with custom technical knowledge. So ChatGPT would have to be wired to your Gmail. Claude, a different way, would have to be connected to your Gmail using a different API or a different CLI. Gemini as a model would have to be connected again in a different way. But with MCP, now we have a standardized protocol. And any AI that speaks MCP can talk to any tool that speaks MCP. So now we're in an age where we're starting to get more MCP integration into external tools because they know that the AI has that MCP connector. So this is similar to the early ages of some electronics when the USB first came out. Before the USB, there was different types of connectors for different pieces of hardware. So if you had a Mac computer or a PC or a digital camera or a printer, it might have a different type of connector for each thing and each other thing to connect to another, and there was a problem there. And then the USB, and the U in USB stands for universal, made it so that you build a connector once and now everyone can use it. So we build MCP and every AI can use it. It's like a USB for AI. Same plug, any device. How do these all connect? API, CLI, MCP, they're the plumbing. That's the flow that AI and AI workflows and AI agents, they flow the data and the tools through these connectors. So if AI is the model, the brain by itself, it can only read what you paste into it. But with API, apps call AI through the API. So an app can use, say, an AI model through the app itself through an API. With CLI, developers can test AIs using those CLI tools. And MCP, well, we'll see, right? When we're designing something like an AI workflow, we have AI plus a sequence of steps. We looked at that in our last lecture. With API, every step usually involves an API call. With CLI, the scripts will orchestrate the workflow. And with MCP, that's a little optional, but it's really handy if that workflow needs access to the tools, which it obviously will. And as we'll look at in our next lecture, when we're talking about AI agents, where they're going to act autonomously, they're going to make decisions on their own, which steps to take. With API, the agents can call those APIs to look things up. And with CLIs, the agents can run the CLI commands to do things autonomously. And with MCP, now the agents can discover which tools they're connected to and make decisions based on that. The more an AI system has to act in the world, the more it learns on all three of these. All right, so let's wrap up today with some critical evaluation to optimize our AI. When we get output from an AI, we can trust it, but we need to verify it. AI will always sound fairly confident, perhaps maybe overconfident in the output, whether that output is right or wrong. The ability to spot when AI is hallucinating or biased or just plain wrong is the skill that separates someone who uses AI properly from someone who depends on it badly. So hallucination is when AI generate things that sound true but aren't. And there's an example there in the 2023, a US lawyer actually filed a court brief citing 6 cases where ChatGPT had invented all 6 of those cited cases. None of them actually existed. We can also look at bias, which we've looked at in Unit 1 of this course, where AI reflects patterns in the training data. A good example is an image detector when asked for a doctor, historically would return mostly men as a bias. A nurse would be mostly represented as a woman, which is the bias from its training data. And then last, that confident wrongness, where AI sounds equally certain whether it's right or wrong, right? The tone never changes. You just have to override the instinct to trust whether or not the fluency is there. So one strategy to employ in critical evaluation is one that's called the 80-20 rule. It's kind of this framework for working with AI output. So think of AI handling the drafting of your document, that it's going to do 80%, or whatever it is you're using AI to do, that it's going to take on 80% of the work. So for example, if you're having AI help you write an email, it's going to write 80% of it, right? So AI, what does it do well? It drafts, it provides that, that standard consistency, the boilerplate, so to speak. It will summarize things, long content. It'll generate ideas that you can look at. The 20% is where you are the human in this loop. This is what you have to add. You have to add the judgment part. Is it actually what the 80% done correct? Is it in the right context? Does it fit my situation? And polish it up, right? Make sure it has the correct voice, the correct accuracy, all the little nuances. That's your part. So it's still incredibly useful sort of framework that it's going to do 80% of the work, and then you come in for your 20. Thank you, everybody. I hope you found that useful on AI optimization, and I hope you have a great day.